Hello, this is Mr. Zamoyski, chemistry teacher at North Tonawanda High School, and this is the pre-lab video for the third quarter lab titled Percent Water in a Hydrate. Last semester we did a series of labs that were separations, and we took advantage of the physical properties of the different components of a mixture to separate the mixture into its component parts. We're to do another separation as well related to one which we call the distillation, which is a separation by boiling point. But it's not exactly the same as that, but it's the same principle. In this lab, we're going to look at something that's known as a hydrate. What a hydrate is an ionic compound that has absorbed water. And what happens to the water is it becomes part of the crystal structure or the lattice of the ions within the ionic compound. If we look at our water molecule here, it is a polar molecule, which means it's asymmetrical. And as a result, it's going to have two sides, a positive side and a negative side. The negative side is going to be closer to the oxygen because oxygen is more electronegative. And the positive side will be closer to the hydrogen because the hydrogen is less electronegative. What ends up happening is the negative side of the water molecule is attracted to positive ions, and the positive side of the water molecule is attracted to the negative ions. So let's see what that looks like if we zoom in on an ionic compound. In a lattice, we have an array of positive and negative ions. In an ionic compound, we have a lattice of positive and negative ions. And we have these water molecules that get stuck in here. So we have the positive hydrogens attracted to the negative part and the oxygens attracted to the positive part. And then the positive side with the hydrogens is attracted to the negative part, and the negative side is attracted to the positive side, and so on and so forth. And this continues. The attraction between the water molecules and these positive and negative ions is so strong that it's really hard to get the water to come out. Normally, if something's wet, like a sponge, you just leave it out in the air and it'll evaporate. But with this lattice, this hydrate, the water is stuck inside of the lattice. It can't get out very easily. And so as a result, we can't rely on the boiling point of water or just the vapor pressure from atmospheric pressure to get this water to come out. So we have to force it out by heating it to incredibly high temperatures, higher than we've done before. And so as a result, for this lab, we're going to need to use some new tools to turn our hydrate into just the standard ionic compound without water, which we call an anhydrous compound.